So this is a lemma from Stephen Abbott's real analysis, and it is essentially another characterization of the least upper bound property. So the lemma goes like this. Assume S and R be an upper bound for the set A contained in R. Then S is the supremum of A if and only if for every choice of epsilon greater than 0, there exists an element A in A satisfying S minus epsilon less than A. Since this is a if and only if proof, we'll be proving both ways. First, assume S is the supremum of A, and let epsilon greater than 0 be arbitrary. Since S minus epsilon is less than S, it follows that S minus epsilon is not an upper bound for A. That actually finishes the proof. There must exist an element in A satisfying S minus epsilon less than A. This has to be true, otherwise S minus epsilon is an upper bound for A. So that's the first part of our proof. What about the converse? Let's assume there exists an element A and A satisfying S minus epsilon less than A. Well, immediately S minus epsilon is not an upper bound for A. What this implies is that any number that is less than S is not an upper bound for A. Well, we know that S is an upper bound for A from our initial condition. But any number that is less than that S is not an upper bound. So consequently, it must mean that S is the least upper bound for A. Thus, S is the supremum of A, which finishes the proof.